LEDs, everybody likes them, everybody wants them. We are going to play with some LEDs today. We have got a bunch of stuff, some PCBs, some panels. Let's play. Now this is not really about the unboxing, so let's just get to it and see what we have here. So, this is some cables, connectors and bits. This is a 64 by 32 panel or grid of colour LEDs. It's a sort of no-name brand. It came from Adafruit. This is a 5 volt power supply, 10 amps, so obviously 64 by 16 pixels. This is quite a lot of pixels. Sorry, 64 by 32. This is like 2048 pixels. So drive those at full power. It's quite a lot of power, so that's why we've got that. This is also an Adafruit board. This is a LED matrix driver PWM I2C. So let's just get it out of its bag so you can see what it looks like. So this is, whoops, this is an 8x8 matrix and it's on a smaller footprint obviously. It's designed for a Raspberry Pi, or in fact anything that can drive an I2C bus. So we'll play with that. And this, some more cables. Screws and standoffs. This is a 16 by 16 matrix. Came from Pimoroni. It's an LED, it's a 3-colour LED. It has its own microchip built in. They call this the Ubercorn. And this is driven by a Raspberry Pi. You just plug it straight in here. But we will find other ways to drive that. This, I think, is a way of daisy chaining multiple of these displays. And then down here we have got, this is a Mega 2560. This is an Arduino Mega, but it is an Elegoo brand version of it, which was, you know, quite a lot cheaper. And this is a prototyping board. A little bit of breadboard there. But this is a prototyping board which just sits, plugs into the Arduino and lets us build circuits. And we're going to use this to talk to this. I'd like to thank the sponsor for this video, PCBWay. They can make circuit boards of all kinds, whether you design them yourself or select one of their shared projects. They can even assemble the boards for you. Ideal for makers and tinkerers alike. And delivery times are super reasonable, with prices starting from just $5 for up to 10 boards. Check them out at www.pcbway.com. And now, back to the video. So we're going to start with the 64 by 32 matrix. Now we're going to power it and drive it from the Mega through this prototyping board. Adafruit does make a bonnet for an Arduino directly to drive this, but it does not work with the Mega because the pinout is different, and in any case they haven't had any for like months. So I've printed out a set of instructions to prototype one, and we're going to follow that. It's basically a matter of just wiring up a connector so that it plugs into this, which plugs into the back, like that, and then that's going to plug into this board. And similarly, the power comes in these big cables that plugs into the back here, and we've got an adapter for a barrel jack, so this can go into that, and the barrel jack goes into the power supply, or possibly we'll route it through the Arduino. We'll figure that one out. So this is basically what it's going to look like. We're going to put a header onto this. I've only got 2 single pin connectors, but double them up and they become a double pin header. That's going to go in there somewhere, like that, and then we wire it up to these cables. And basically this header is 2 sets of RGB signals. Basically the panel is driven in 2 halves, so sort of it scans and it goes zum, 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 zum. Something like that. I'll try and put a proper animation up for you just to see how it works. So we've got, for the 2 scan lines, we've got RGB, and we've got a clock signal, we've got a latch, an output enable, and 4 signals A, B, C, D. These determine which section of the LED panel that we're talking to. It's a sort of matrix array thing, and it latches into all these little chips on the back, which then drive the LEDs themselves. So this is not buffered, you have to actively drive it, which means that you need quite a fast processor to actually drive it. And this is the connections for all these things, and we will set about building it. I've actually found a shrouded connector that is the right size, so instead of these I'm going to go with this. Now the way I want to mount this is basically this way up, so that the cables are coming in from the underneath. This is the bottom, and so this wants to go somewhere in the middle, about there. It doesn't matter exactly where it is, but that is going to fit quite nicely. And we need to make sure that we know that pin 1 is at the top, and so when we do the circuit then it's going to be the same way around, like that. And of course we're going to be doing it from underneath, and it's not labelled underneath, so we need to be doubly careful about getting it right. So let's just solder this in, and then we can start wiring it up. Now, it wouldn't be one of my videos without a soldering montage, so let's get started. Okay, that's the connector soldered on. So now we're going to look at the wires. I've got my box of miscellaneous wires that we can rummage through and find appropriate bits of wire. So the first thing that we're going to wire up is the ground wires. So I've got a Sharpie pen, and I am going to mark them on the board because it's a little harder to tell underneath. And where do they go? It says most Proto shields have tons of grounding points, so you shouldn't have difficulty. So I'm going to use black wire for the grounds. Now these are pass-through pins, so the sticky up ones on the bottom are the ones that are going to go into the Arduino itself, and these pads behind or in front on that side are the ones that we can connect to. They are just connected straight across. That's the ground wires done. Okay, so I'm connecting RG and B. I'm going to connect these on the top because they can go through here. and then through the hole at the bottom. These connect to this connector here. And since this doesn't have a pass-through connector already soldered in, we can just solder it through the holes. Okay, that's the RGB wires. So the signal wires, or at least the control wires, these are going to be yellow. There we go, and that is done. To power the Mega, we need 5 volts. To power the LEDs, we need 5 volts. We've got 5 volts. Now, the Mega has got 2 inputs. It's got USB input and it's got a barrel jack. If we want to use the barrel jack, we have to supply more than 5 volts. We have to supply a minimum of 7 volts. But because we've only got 5 volts coming from here, we need to supply it through the USB. And so what I've done is on this barrel jack adapter, this gives us the 2 outputs that go to here, and I've also hacked a USB cable so that this gives us 5 volts into the USB. I've already installed the Adafruit demo program onto this, so let's just plug in the shield. We can connect the panel to the Arduino. We can connect the Arduino to the supply, turn them around like that, and this is the point we switch it on and see if it goes. Look at that. So that is our 32 by 64 matrix RGB, red, yellows, greens, blues, whites, purples. I've spent some time studying the Arduino IDE and getting a basic understanding of how these panels work, at least from an Arduino perspective. So what I've done here is take the demos from a variety of different panels and merge them into a single slideshow. I'm still getting the hang of it, so it's a bit rough and ready. I'll dim the lights because it looks better in the dark. This second panel is our 13 by 9 RGB matrix. It runs off I2C, so it's basically a serial protocol, and we've got a choice of these tiny connectors, which I don't have one of, so I'm not going to use that, or regular pins. And we're going to go through this piece of breadboard and onto the Arduino. Now this uses a single chip, which is an IS31FL3741, bit of a mouthful. That handles all the driving code for each individual pixel. So it's, instead of there being a chip for each pixel like you would see in in a NeoPixel type display. This has one chip that addresses all of them. So we just need to put this connector in, and I'm going to have it facing downwards so that we can plug it into that. On the back you can see we've got solder pads that we can set the I2C address from OX30 up through OX33. So we can plug it into the breadboard. So we've got VCC and ground, and then we've got clock and data. So that should be our circuit connected. So now we need to go and program up the Arduino. Okay, I've programmed it up and I'm going to power it off this battery pack this time around. It's just a matter of plugging it in. And there we go. That is very bright. Here's another one. Let's turn the lights out and see what it looks like in the dark. This is our third panel. It's called the Ubercorn and it's by Pimoroni. Now I said earlier that these were NeoPixels, but I think in fact they're not, although they do sort of behave like NeoPixels. Now on the back, apart from all the fun little drawings and scribbles, you see we have a header for a Raspberry Pi. These, I believe, are headers so that you can actually chain multiple ones together. I don't know what the pinout is of those. It doesn't actually say on the board. So whether they're actually usable on their own, I don't know. But we have space for a Raspberry Pi. We have power. Now this will take either a Pi 0 or a Pi 3 or Pi 4. The interesting thing is if you try and plug a Pi 4 in there, it won't go because of the sockets. So they have provided an extension mounting thing so that you can raise it up. But we are going to use a Pi 0, sorry, a Pi 02W. So that's plugged in, USB is plugged in. And this goes into the USB power bank. Well, that did nothing. So having destroyed one SD card, don't worry, the Pi itself is perfectly okay with another card in it. I've decided that I'm going to try this panel out with my Pi 400 and using the GPIO expansion card, which we've seen before in other videos. I've loaded the Pimoroni Unicorn HD library and installed their example code, so we're going to run that. And I'm just going to run through some of the demos. This is what they call their candle. The more classic demo. Now, one thing you do notice with this is that the pixels are so much bigger, and so therefore you can see the actual individual red, green and blue LEDs quite easily. And also because they're so far apart, you have to kind of squint a bit to see patterns and images and stuff. So next one, this is a classic game of life demo. You see just turn the lights right down. And this is loading small ping images. So that's the Ubercorn. It's not NeoPixels, but the library treats it as if it was NeoPixels. So it uses the NeoPixel library and the SPI interface. You can actually see the comms LEDs on the board beside it, showing port activity. Now here we have a string of LEDs that are known as WS2812B, and WS2812 is basically the chip that is embedded inside each individual LED package. The B in the designation just means basically that this version has reverse voltage protection. So if you wire it up backwards, then it's not going to die. Of course, if you wire it up the strip backwards, then it's still not going to work, but that's a different matter. So this has a simple 3-wire interface. It has plus volts, ground and a data wire. The data wire is attached to the Arduino and it happens to be on digital pin 6. You can actually configure it to be any pin you like. The protocol and handling is taken care of by the software, and this is using a thing called the Fast LED library. Now it could also use the NeoPixel library. NeoPixels is just Adafruit's trade name for WS2812 LEDs and the whole series of protocols that surrounds this. And this is the same library basically that we used for this board, except that these LEDs don't have the embedded IC, the embedded chip. So these are just straight LEDs, and you can see if you zoom in, these are actually 6 contact LEDs. So it's a separate package, red, green and blue. whereas these are actually 4-pin LEDs, and they have the signal that is driven by this. Essentially, it's a serial wire protocol. So let's plug it in and give it a try, see what it does. This is just some demo software that I've loaded on here, and it takes a moment. These are all individually addressable LEDs. You basically address them through the protocol. It's very easy at a sort of high level that the library runs at. But I don't know what it would be like if you were writing it sort of from scratch. It would be interesting to find out on maybe another board. Could we drive this protocol, for example, from an 8-bit micro? That might be an interesting thing to find out. Would it be fast enough even? You might be wondering what this has to do with retro computing. Well, hopefully over the next few weeks I'm going to be trying to drive these LEDs, these panels that we've seen today, from a number of 8-bit computers, and I shall see basically how far we get. So that's basically it for this video. Thank you for watching. Please like and subscribe and comment in the section below. So until next time, see ya. Bye. Bye.